Good morning, student. Let's start today's class. Okay. Today we are going to discuss about the types of, or we are going to start the types of configuration or transistor configuration. We discussed that there is three types of connection or configuration of a transistor. One is common base configuration, one is common collector configuration, one is uh, a, common emitter configuration. First of all, start with common base configuration. Okay, now let us see what happened in common base configuration and what what do you mean by common base configuration. Okay, in this circuit arrangement, in this circuit arrangement, input is applied between, see, input is applied between emitter and base. Okay, and output, this is input, emitter and base. Output is taken from collector and base. Okay, you see, this is input, this is input, this is output. Okay, the input is emitter, base. Okay, from this we take, we give input, and the output is taken from collector and base. Okay, so you see that here the base is, here the base is common for input and output also. Okay, so the name is common base configuration. Okay, the base is common for input and output also. Okay, now see, now let's see what is the current amplification factor. Okay, the current amplification factor is the ratio of output current and input current. Okay, here output current is the output current is IC, and the input current is IE. Okay, that means collector current is output current, emitter current is input current. Okay, so the current amplification factor, which is alpha, is del of IC and del of IE. Here del of IC means change of collector current or output current with respect to the change of IE current. IE current means input current. Okay, so here del is there, means there is change, or not constant IC, there is change is there. Okay, and at a constant, which is constant, at a VCB, CB means collector and base, this voltage is constant. Okay, when we calculate current amplification, we constant this voltage. Okay, now now it is clear that the amplification factor is less than unit. Okay, because uh, because the in any case there is no case where IC is equal to the IE. Okay, you know that IC, okay, is always less than the IE, because the input current or IE is not entirely transferred to the IC. There is some leakage are there in base. Okay, so IE is uh, or IE cannot be equal than IC, equal with IC. It should greater than IC. Okay, IE in generally greater than IC. So that IC by IE, okay, the if IC is less than IE, then it should the alpha always less than 1. Okay, less than unit. Okay, in practical case, you remember this, in practically or commercially you used common base transistor, the current amplification each range between, or is 0.9 to 0.99. This range, between this range the value should be there. Okay, now what is the expression of collector current? Okay, the whole emitter the whole emitter current does not reach the collector. Okay, it is because a small percentage of it goes as base current due to the electron hole combination occurring in the base area. Okay, so just now I told you that the all the emitter or the whole emitter current is not transferred or does not reach the collector. Okay, so some leakage or base current are there, and this base current is due to the electron hole combination at the base region. Okay, and uh, and as the collector base junction reverse bias, therefore some leakage current flow due to the minority carriers, therefore total minority carriers. That means the collector base junction, this collector base junction, okay, let's see, this is transistor, this is collector, this is base, this is emitter, this is forward bias, emitter, base, but this collector base is also always reverse bias. So for that reverse bias, okay, there is a current flow in the base due to minority charge. Okay, that is called leakage current. Okay, so therefore total collector current, so therefore total collector current consists of the part of emitter current which reaches to the collector, which is alpha IE, because here collector current IC, okay, equal to alpha I, where it is coming from, this, okay, because alpha I is IC by I, so IC equal to alpha into I. Okay, so here you see the first part is alpha IE, the part of emitter current which reaches the collector, okay, which is alpha I. Then second part is the leakage current. You see here the I equal to alpha I plus 1 I leakage. Okay, here if IE, here you see, if IE, this IE is 0, a small leakage current still flow in the collector current. Okay, this leakage current is called ICBO, which is collector base current with emitter open. Okay, you see here the emitter is open. Okay, but there is there is still a leakage current flow, which is ICBO, or collector base current when with emitter open. Okay, which is ICBO. Okay, now IC equal to alpha IE ICBO. Okay, then we previously know that in ideal transistor IE equal to IC plus IB. Okay, previously when we studied about BJT, okay, I told you that the emitter, okay, in ideal condition, okay, there is no load or there is no uh, external uh, applied, okay, external biasing applied, there is always IE, this is IE equal to IB and plus IC. Okay, so there, if there is no loss, okay, so this is the, remember, this is the current condition of or of a transistor. Okay, so from that we use IE in place of IE, IC equal to, in place of IE we put IC plus IB. Okay, and after solving, okay, you get IC equal to alpha by 1 minus alpha IB plus ICBO by 1 minus alpha. Okay, so here, do you remember this? Okay, then the now let's see what is the characteristic of common base connection. Okay, first let us see what is the input characteristic. Okay, this is, remember, this is the input characteristic. Okay, in input characteristic I and VEB. Okay, it is the curve between IE and VBE, which is emitter base voltage. Okay, then the point will be remembered, point need to be remembered that that first point, the emitter current IE increase rapidly with small increase emitter base voltage. Okay, that means from this to this, the input current IE increased rapidly with small change in VEB. Then second point is emitter current is independent. Okay, here from here to here, the emitter current is independent. Uh, Independent of collector base voltage. Okay, so here you see uh, nearly constant. Okay, or a little bit of variation. Okay, very little bit of variation. Okay, now this is the input characteristic. Okay, sorry. Now let's see 1 minute.